Welcome back to topic 43 for Algebra 2, inverse variation. In part 3, we're going to learn about joint variation, as well as do some translations and applications involving direct variation, inverse variation, and joint variation. So joint variation is a function that's represented by the form z equals k times x times y. K is still our constant of variation, and it's still non-zero. This would read as z varies jointly as x and y. Now this can be a product of two or more quantities. Let's move into an example. The variable z varies jointly with x and y. Also, z equals 60 when x equals -4 and y equals 5. We're asked to find z when x equals 7 and y equals 2. Let's write our form. Z equals k times x times y. Plugging in for z, we're plugging in 60 equals k times -4 times 5. If we simplify on the right-hand side, -4 times 5 gives us -20 times k. Remember, multiplication is commutative here, so we can flip the order, but we'll still get the same product in the end. That equals 60. In order to solve for k, we can divide both sides by -20, and k equals -3. So our new equation would be z equals -3 times x times y. Plugging into part 2, we get z equals -3 times 7 times 2. So all we have to do is just straight multiplication. -3 times 7 is -21. -21 times 2, z equals -42. Now using what we learned in part 1 and part 2, we're going to apply some translations and applications. So we're asked to write the equation to represent the given relationship. First example already looks familiar. Y varies inversely with x. Remember to include your constants here. So y equals k divided by x, since it varies inversely. Next, y varies inversely with the square of x, so a little bit different. Y equals k divided by, now instead of just x, this is going to be x squared. Z varies directly with y and inversely with x. So z is going to equal k times y, but divided by x because it's inversely related to x. It varies inversely, I should say. Next, r is inversely proportional to s, but directly proportional to the square of t. So r equals k times t squared, but it's inversely proportional to s, so it's divided by s. Next, m is directly proportional to n and inversely proportional to s cubed. So m equals k. I always like to start off with just writing my constant of variation, just so I don't forget it. Since it's directly proportional to n will be in my numerator, and it's inversely proportional to s cubed. Last but not least, the power P generated for a translational machine varies jointly with the acting force over a distance achieved and inversely with the time. So this is pretty wordy, but let's just break it down. The power varies jointly, so remember a constant variation, with the force over a distance. Remember, this is the product of two or more quantities. But it's inversely proportional to the time, so it's divided by t. And that is part 3 of topic 43 for Algebra 2 on inverse variation. In part 3, we kind of compiled everything that we learned in parts 1, 2, and 3. Thanks for watching.